Now we're going to hear a completely different viewpoint because we're going to be hearing about computational storage, which basically eliminates the need to have any data shuffled around between storage and computing. To speak about that is Theodore Mora, who is he's Executive Vice President of Marketing and Operations for ScaleFlux, a computational storage company. Thad actually comes with quite the background that he worked for SandForce from its inception right through it's being taken over by LSI, and in turn through that it's being taken over by Seagate. Before that, he worked for Mellanox and for Galileo Technology, two other startups that both had successful acquisitions or IPOs. He has a BS degree in EE in computer science for UC Berkeley. Now, yesterday we had a keynoter, Jeremy Werner from Toshiba, and he told me something that I hadn't really noticed about Thad. He said, this guy worked for Galileo with a successful IPO, and Mellanox, successful. And now his last place after that was SandForce, which was successfully acquired. And this guy seems to have a real Midas touch that every company he works for turns to gold. So I guess the lesson to be learned here is that we ought to be paying an awful lot of attention to Thad as he moves through what he's doing now, with computational storage. So without anything further, let's welcome our next speaker, Theodore Mora.
Awesome. Thank you, Jim. Wonderful introduction, and good afternoon, Flash Memory Summit. Before I start talking shop, a little housekeeping. Wanted to let you know a little secret. The answer to all of your questions, at least for the next 25 minutes, is computational storage, okay? And for those of you who show me how smart you are and get up and yell computational storage to my questions, you are going to be rewarded on site with a $20 Starbucks gift certificate. Yes, there are ScaleFlux folks roaming the aisles. They're listening for those who are the loudest and the proudest. Now, this is not the Oprah Winfrey show. Not everybody gets one, okay? So, show me your spirit. So, why don't we just kick this off right now? Question: what transformative technology are we going to learn about right now? Whoa! Okay, you get a card, you get a card. I'm just pointing into the light. That's right, computational storage. Now, when people come and talk to me about computational storage, the number one thing they ask is, how is computational storage solving problems today? And since we coined the term in 2017 right here at Flash Memory Summit, that was just 2 years ago, we've come in contact with a lot of different folks from different industries, different workloads, and we've seen a lot more workloads just gravitate to computational storage. So one example is an online e-payments company, and they are a part of their country's transition from a cash-based society to all of the transactions now happening online. And in their journey, they've seen the number of transactions their infrastructure needs to scale is 3 times year on year. That's the growth rate they're expecting. They today run all their transactional database and their analytical workloads on ScaleFlux. Another one of our customers is a car manufacturer. Now, as we all know, they're all building their autonomous driving platforms. They're ingesting terabytes of data for each car every day. ScaleFlux is now running in their analytics platform to take their analytics job runtime from days to hours. Another customer of ours is in the ad tech trading platform. They have hundreds of thousands of traders on the platform. Sometimes it's idle, sometimes it's not. But they need to guarantee the consistent latency regardless of the traffic going on the platform, because they're trying to broker millions of impressions on all these different ad sites. They published that their transactional database is taking 1 billion rows an hour being ingested. They run ScaleFlux on their NoSQL database. An online cybersecurity company, they wanted to go build out a platform to secure 1 billion mobile devices and prevent all of those devices from any fraudulent activity. They also run ScaleFlux on their NoSQL database. And an online gaming company, they were in process to scale their platform from 1 million to 20 million active users at a time, collecting all of their data, building brand new games. They run ScaleFlux. So what we see here is a common theme, something that you've heard a lot about, a lot of data growth. But really it's about the valuable data and being able to generate insights from those at a much faster pace. So the next question we get asked, well, how do we do it? Like, computational storage is kind of like this newer idea. How do we do it? Well, the first thing we do is we have a device that can go into every single commodity infrastructure server solution, okay? Standard PCIe form factor and power envelopes, you've got to be able to fit those and go into every application. Our first generation product supported up to 8 terabytes of TLC flash. In addition, in order to access that flash, we specifically have chosen an open channel block-like storage interface. Now, why do we do that? We did that because we know as new customers adopt different types of workloads and the compute is going to change to be these kind of heterogeneous architectures, people want the ability to tune those storage I/O interfaces very easily. We also include a number of I/O optimization features, things like atomic writes and streams, to make the I/O to the storage as optimal as possible. But as is the trademark with computational storage, and you're hearing more and more about this concept, it's about the compute capabilities being brought locally onto the drive. And we've done this through hardware adaptable fixed engines. We leverage state-of-the-art Xilinx FPGAs. Shout out to Xilinx, one of our investors. Can I get a woo? Somebody? Yeah, okay. Very good. And the way we use those hardware engines is we leverage existing software APIs. So these software APIs that typically use the CPU for a particular acceleration function, we now abstract all that complexity, we push it down, the compute function down to the drive, and then we integrate all of this computational storage goodness into a bunch of turnkey applications. Simply plug in the drive, run the application faster, and away you go. But as we worked with more and more customers on these different workloads, we get different feedback about how their data and the demands on this data is changing. But what's really interesting, and I wanted to share with you, is they're all trying to get to the same common goal. Okay? The folks we work with on big data, they're all looking for solutions that can accelerate their analytical workloads. They want to run faster. And one of the key things, which was highlighted by the IBM presenter yesterday, was this idea that they want access to the latest data. Because the worst thing in the world is you run these analytical queries and it's on stale data. So what do? You get a stale answer. That's not good. But then we also work with a bunch of folks who work on fast data, low latency data. These folks, they're all trying to see how can they support a fast-growing data set. And they, of course, also want to start generating immediate analytical insights from that data. So the common trend is all about exploding data sets, but immediately being able to generate valuable insights from that data. So we see they're all trying to get to the same place, right? Data and infrastructure that can handle both fast and big data in the same infrastructure, that's where the value's at. But so far, we've seen that scaling infrastructure on fast data and big data in the same exact infrastructure has been very challenging due to system limitations. So when you take a look at fast data, we're going to up-level this, right? Think of your Excel spreadsheet. Fast data in a transactional database is typically entered in this row format. There's lots of different types of data that's entered with every single transaction. Very low latency, and the compute is very focused on reliably registering these transactions. When we take a look at big data, these systems and infrastructure are architected for other priorities. It's all about capacity and getting as much data into them. And typically, when you look at an analytical database, it's stored in a slightly different format. The data is stored in more column-oriented format. The same types of data are all stored with each other. Now, one of the issues, again highlighted by the IBM person, I'm glad I'm going after him, is in order to get all of this transactional data into a place where you can analyze it, there's often this kind of slow, very intense, resource-intensive migration. You got to take this data that's formatted in one way and put it into another format. And in order to start executing your analytics, nobody only wants to look at a subset. We've talked about that, right? You want to look at all your data. You want to make sure you have the most recent data. Nobody wants to kick off batch processes, because by the time you're able to kick those off, new data's come in, and of course, nobody wants to go through data migration. Coffee time. Coffee time. So, what storage solution do you think unifies fast and big data?
Computational storage.
Ah, you got it. Computational storage. Coffee cards, please, guys. Come on. Let's keep these people happy. Okay, so computational storage unifies fast and big data in the same infrastructure. So if you take a look at traditional data, what happens? All of the data has to move up to the CPU, regardless of any type of data manipulation. And right now, we're looking at analytical query, that particular operation. Okay? So there's an extract, transform, and a record filtering function that's very compute intensive that the CPU has to perform. Okay, what's the big deal? Well, we just talked about workloads are expanding. They're growing like crazy. And when you're sending all of this data up to the CPU and making the CPU responsible for that function, CPU bottleneck. Well, with computational storage, what do? We move those compute-intensive functions down to the drive. We parallelize that workload. So it's all happening at the storage. Now, not all the data needs to move up, just the answers. We only want the records that match the queries. All of that enables us within the same commodity infrastructure to keep the low latency fast data transactions happening to the flash. At the same time, you can scale your big data analytic workloads with capacity. We can do this all on commodity hardware, which everybody really wants to do. Congratulations, you have just unified fast and big data. And to show how ScaleFlux has been in this process to demonstrate this technology, we use a MyROX database. MyROX leverages MySQL. It also uses RocksDB as a key value store. I assume most of this audience is level 7 and understands some of that stuff. RocksDB is where we've actually made some changes where we can actually push down query predicates through the key value storage engine. And we also pass a bit of context on where those record queries are to be able to do these query functions at the drive level. So what I'm going to show you is the difference if you execute this very compute-intensive function on the CPU, or if you do it at the drive. Now, if the database is one instance and attached onto one drive, what you find is you can get about a 60% improvement in the job runtime. It's not bad, okay? Now, why is that? The reason why is because you have a faster FPGA dedicated engine. So we make sure that the engine in the FPGA is a fixed circuit that just is focused on being able to do this record querying very quickly. Okay? But what happens as your database scales, your workload scales and grows in capacity? You start adding more and more storage. Well, the CPU doing this record querying function in the CPU job time increases a bit because the capacity gets a bit larger, but at about 4 drives worth, 4 instances going on, we start to see the CPU becomes compute bound. We've used all the resources. So as you scale your database and you're adding more and more records that you have to go through for this analytical query, things get a little nonlinear. But with computational storage, what happens? It's a much more even scaling as you scale capacity because we have parallelized that particular compute work function down to the drive. You can now scale performance with capacity. Let me repeat that. Scale performance with capacity. Now, for all you techie guys out there, you want to see the data. We have it all. I'm not going to go into details into this because I've been told not to, but come to our booth. We want to share this data and show with you how on the compute side, we have all the CPU traces and show where it becomes compute bound, and how using computational storage opens up the CPU, and those cycles will be used to maintain your transactional database. We also have all the storage I/O workload traces where you can see all the reduced data movement, which then doesn't pollute the DRAM cache. When people talk about reducing the data movement, it's about not polluting the DRAM cache, okay? Because that data has to go somewhere. Computational storage, the I/O is much more direct. We only report back the records that match the query. And what's really exciting about this technology is not that we can do POCs and demos and things of that sort, but really how will this technology impact infrastructure at cloud scale? Last year at Flash Memory Summit 2018, we announced our relationship with Alibaba and how we're working very closely with them on their PolarDB database infrastructure. Now, just to remind, PolarDB is a cloud-native database with distributed storage. And one of the key features that Alibaba Cloud has been promoting about PolarDB is the ability, interestingly enough, to do transactions and analytic workloads on the exact same infrastructure. And the reason why is no lag for analytics. Okay? They also want to be able to reduce the storage capacity. So you reduce your storage footprint because you only keep 1 copy of that data. And they've also embraced computational storage to make this happen, delivering the best price performance for the infrastructure. And it's actually not just running things faster, but it's a new class of analytical responsiveness. Because as the transactions are coming in, you can immediately kick off those analytical workloads. And of course, it's got to be done in commodity server and infrastructure at those price points. So some more data that has been generated based upon this technology. What we've seen is full database scans happen just 3 times faster through the infrastructure. And as a result, the memory, CPU scaling is 3x. It's an immediate benefit based upon the analytical query acceleration. It's not just the scaling that improves, but giving a much better user experience to all of their enterprise customers, being able to get these queries done in a much shorter amount of time. So there's a joint value proposition, not only TCO, but also performance related. Computational storage is making this now happen at cloud scale. More coffee? What storage solution offers a new paradigm to scale compute resources with workload capacity? Man, you guys are brilliant. You guys are brilliant. I like it. Very intelligent audience. So, a new paradigm for scaling infrastructure. The first thing, we want to scale capacity and performance together at cloud scale. Of course, a new class of service, right? No lag for analytics. We want infrastructure scaling, TCO benefits, and this idea of parallelizing intense compute functions at the data. That's what computational storage is about. Now I got a couple of other key points here. The first thing is we have been talking about application acceleration. Computational storage being used to accelerate the application functions. And we've been focused, and I've been sharing with you our journey into a lot of the database workloads, things like record filtering and extract transform. Of course, there's a whole load of markets out there that this technology is being applied to: AI and machine learning, genomics, content delivery, search. But there's a whole other class as well of functions to accelerate. And we categorize a lot of these functions as being very fixed algorithm, fixed engine, and doing a lot of bitwise manipulation and comparisons that are typically required across all the data. So those same traits also apply to infrastructure level functions. Infrastructure level functions, things like, in the storage level, compression, erasure coding, security. You guys are familiar with all of these. And it's with great pleasure I introduce our latest generation of computational storage drive, the CSD 2000. Now, this is industry's most advanced computational storage drive because what we've done with this product is we have integrated both application level acceleration with the in-storage analytical database, but we have also integrated to support that with the best baseline storage I/O by integrating data path compression and decompression. Okay? This happens naturally on every single drive. What's the value of the data path compression and decompression? Well, all of you, again, level 7 folks out there in the audience know the performance of SSDs. So what, all the way on the left is read and all the way on the right is 100% write. We know what happens is more write traffic comes into the SSD. Things start happening in the background, right? And this is a state-of-the-art NVMe SSD, and what we see is garbage collection starts to kick in. So you get very high read performance, but as things start to trend more towards the right side, performance starts to tail off. Of course, with data path compression and decompression, what do you get? You get much more consistent performance across read-write workloads. Now, this data here is on FIO. We're assuming a 2.5 to 1 compression ratio. But what you see here is, again, much more consistent read-write performance with the data path compression, decompression. Now, when we start to take a look at OLTP workloads are what, 90-10, 70-30 read-write, you get an immediate 40 to 70% bump in performance. Pretty cool. Plug it in and see that happen right away. So with the CSD 2000, a bump in the OLTP performance, very consistent, and a term my friend Joe Unsworth uses at Gartner, penalty-free. No CPU overhead, and what's really, really, really critical is no application latency to use compression. This is both on the compress and the decompress side. Pretty cool, pretty cool. So having this as a base is awesome because when you start applying this to real-world workloads, things like OLTP databases, this happens to be MySQL, plug in a certain drive, plug in our drive, 50% higher read-write performance on the Sysbench benchmark, okay? But some of our customers say, well, we want to get a little bit better value out of the drive. We're dollar per gig very sensitive. Our databases are exploding. Well, you have the option. You can either buy double the capacity, or you can provision our drive as double the capacity. Still get 25% more performance, half the spend. Okay? And this is provided transparently in the drive. I think this is the last opportunity for coffee. So okay, I think. Very quick question. What storage solution cohesively opens application and infrastructure computing bottlenecks? That's right, that's right. So with the CSD 2000 introduction, we are holding to the 3 tenets that computational storage is all about when we introduced it 2 years ago. The first, responsive performance. Best OLTP and mixed read-write workloads. We are unifying fast and big data by moving heavy compute functions down to the drive for analytical queries. And of course, we minimize the data movement. The second is about affordably scaling. These technologies are all about, one, reducing the dollar per gigabyte with the transparent compression decompression. going to become very, very important as more and more QLC technologies move into the market to try to eat into that hard drive storage space. The next is performance with capacity. We talked about that, right? As your capacities are growing, you're maintaining your runtimes on those complex workloads. And the third, this goes right into commodity infrastructure. The third key tenet that we talk a lot about is agile infrastructure. Super critical to be agile. So we're providing transparent level benefits with the compression and decompression. It's in-system and hardware updatable because we use programmable hardware with our FPGA technology. In the last couple of years, we've provided our customers new hardware features by simply updating their FPGAs in-system. Really happy about that. And the third, you got to be very easy to tune to different applications and workloads. Okay? That's where our open channel like storage interface has paid a lot of dividends. Now, I'd be remiss not to mention how computational storage not only has a growing set of applications, but a growing set of system vendors. Let me highlight two of them. First, Dell EMC, the Extreme Scale Infrastructure Group. They happen to be in our booth, so please come say hi. They're helping us promote the virtues of computational storage, specifically in their Dell R640 and the R6415 platforms. These are your award-winning standard 1Us that a great majority of our computational storage drives are going out into. And there's also different types of platforms that are now being worked on. This is one particular platform from a company called Middle Canyon. And what they are integrating, NVIDIA GPUs, SmartNICs, and ScaleFlux computational storage drives, integrating the latest state-of-the-art technologies, specifically focusing on real-time AI and machine learning streaming workloads. So a lot of innovation is coming forward to integrate all of these new compute, networking, and now storage elements into the same platform. Now I'd like to share with you a little bit about what do we see the future is for computational storage. How is it proliferating? How is it growing? Well, the first thing, it's all about the apps. Applying this technology easily to different applications so more and more customers can more easily use it. That's why one of our goals at ScaleFlux is to make a lot of the compute functions as transparent as possible. Some of them are completely transparent, like compression. Other ones, we want to make it much easier to use, and a big part of that is standardization. So we've seen from the SNIA group, they are now, we are now all working on, within the SNIA Computational Storage Technical Working Group, standardization for how to activate these compute functions. Because whether it's vendor A's drive or vendor B's drive, from an application standpoint, you want to make sure you look down at the drive, you know what it can do, it's ID'd correctly, and number two, the activation for the compute is standardized. Okay? Again, make it easy for application developers to utilize this new technology of computational storage. And the third, which is really, really important about the technology, it's about pipelining compute functions on the drive. So we talked about application acceleration functions. We talked about infrastructure acceleration functions. Putting them together and adding more into that pipeline on what the drive can do is really where you're going to see even more acceleration for these applications. It's going to be much more efficient usage of those compute resources down on the drive. So when you take a look at infrastructure and the evolution of infrastructure, 10, 15 years ago when you heard about compute, we all thought about CPUs, right? But now today it's commonplace. Previous speakers talking about FPGAs, GPUs specifically, right? There's all these new compute elements in the infrastructure that are absolutely critical and relied upon. When you talk about networking, right? Networking used to be just NICs, but now it's all about smart NICs and intelligence being added to the NIC card. And now we see storage, right? storage, the growth of storage is going to be about how can we really accelerate applications, and that's where computational storage comes in. In fact, all of these components are classified as what we call domain-specific compute elements of the data center. They are all becoming more and more critical to scale application performance as these workloads continue to increase. And the fact of the matter is the number of compute drives, the number of storage drives inside the data center, it's the #1 volume, right? It's going to have the most impact to these applications if we can utilize these capabilities as efficiently as possible. So we are really in this age now of the rise of computational storage. Unifying fast and big data, that's the big idea. New paradigm to scale performance with capacity, and of course we have a growing ecosystem we're shipping in production. Thank you very much. We're ScaleFlux. We're deploying computational storage at scale. Come visit us. Our booth 113. You can get a better picture painting of yourself right on site, real time. And of course, lots of demos of computational storage. Thank you so much.
Thank you.
Okay.
Oh, you can get that. Thank you.